Hello, hi. Yeah, let me see the second video of PCI. First video, as we seen, what is meaning of protocols? What are the different types of protocols? Uh, what are the disadvantages we will see? What is the issue of parallel protocols? How bandwidth is affecting using in the SKU point of view? So, as we seen till now, some basic definitions and one more we'll see as a half duplex or full duplex or simplex. PCI we'll use as a simplex mode, dual simplex mode. What is the use case? So everything we seen in these definitions in previous video. This video we'll see the layer protocols. As you told, PCI as a layer protocols. What is the need for layer protocols? What is the logic behind that? Before going into that layer protocols concepts, we'll see the OSI model. In computer architecture, we have a OSI model, 7 layers. What is the OSI model? How? What is the use case of these OSI models? What are the layers? What is the each layer significant? We'll see some basic understanding. Then after we'll move on to the straightforward. We'll move PCI. Okay. We'll see the OSI models. In OSI model, we have a 7 layers. The top layer will be the application layer. It's kind of near to user. Let us take one example is whenever you are searching any file something in your browser, it's application will layer will initiate. Then after we'll go with a presentation layer. The presentation it will present like what you are searching, whatever folders you are searching, anything related to server, it will present. Session layers means it's kind of timeout. Let's take as a whenever you are searching in browser, you will see after some time you are not able to generate these files and all. You will see as a timeout related. So a session layer will implement what time it's going to be connect to server, what time it's going to be disconnect to the server. So everything it will control from the session layers. So the remaining floor layers are will be designed from the hardware engineers. Like from the top layers, you will get as a data from the software side. Remaining 4 layers will be controlled by the hardware engineers. These 4 layers will design as a hardware VLSI engineers. So this is the overall of how OSI model is helpful, how layer formation is helpful in a protocols. This is a just brief overview. Coming to layer protocols. What is the use case of layer protocols? The layer protocols is useful for encapsulate and decouples the applications by grouping the distinct segment using their functional roles. So what happen whenever you are using these protocols, these layer protocols, every layer will have a own significant. You are adding something data from here, some other side you are removing something, you are adding here something, you are removing here, you are checking something there, you are sending data some from here. So every layer will have its own significant. So what happen, it will be work same what we expect, and it will improve the stability and testability also as well, and maintainability. You can maintain it very clear. If you see in a transaction layer, it will generate as a transaction layer packets. That is a very simple example. If you send a data link layer, we'll check as a data integrity point of view. File layer, how what is the significant, how encoding. So each layer it's have own significance. As we go forward, you will understand which layer, what is the significance of each layer, what are the features is available. So how to implement it, we'll see in a further slides. But as of now, you understand in this slide what is OSI model, why it's needed for layer protocols to increase the stability and maintainability and improve the so testability as well also everything it's helpful. So this is I want to cover in this slide. Coming to the PCIM, as I told you from PCI is a layer protocols. We have a core. In top level we have a core. From the top level you will get as the instructions, everything, data and all. So what happen, from we have a three layers mainly for PCI. From the software point of view, this controlled by software engineers and embedded engineers. Software control for any software related to PCIe, and embedded engineers will control the drivers needed for that PCI controllers. So remaining hardware engineer will control the these three layers mostly, for transaction layer, data link layer, and physical layer. From transaction layer, whatever data you are getting from the top levels, here this is the data you will get. From here, header and ECRC will added in transaction layer. From the this we called as a, let's assume as of now, master side. Master side, this is a slave side. Let us assume you have a master, you have a slave, you are connected with a master to slave with a PCI. So here you have a layers. So transaction layer, data link layer, file layer. So transaction, from whatever data coming from the top layers, it will add as a header and ECRC from the transaction layer to that data. Then after the say transaction layer packets is generated, it will go for data link layer. Data link added as sequence number and LCRC. After that, file layer will add as a boundary condition. It will start and end, like when packet going to be start and when packet going to be end. So what happen here, in layer protocols, each layer will have a significant, each layer will have features. So based on that features, how to use effectively we are using. If you see, let us assume from transaction layer, let us I want to sending as a 20 packets. Let us example, from the top layer I got a data, I'm generating based on the data 20 packets. So you in data link layer, what happen, you will give as a sequence number 1 2 3 4 5 say like that. So once sequence number is added, file layer will give as a, each packet will have a start and end. PCI itself, I already told, it's a packet formation. Why it's needed packet permission, I will clarify for next slide. As of now I understand, PCI is a packet formation. Based on packets only, data will transfer from one end to another end, so from master to slave. So in this slide, we conclusion like, what is the significance of layers here, what is transaction layer, what is the need for that, what is the data link layer, what is the file layer. Whenever whenever file layer starts, it will start the packet from here start to end. What happen in receiver side, that start end and end point is removed. Here data link layer, sequence number LCRC removed, and transaction layer, header and ECRC removed. Actual data is going to enter into the core. So in this way, from transmitter to receiver, you will add the encapsulate the uh, some some data, and other end you can decouple the data. So this is we call as a transaction in PCI. So in PCI will go same, each packet will go in a through this link in this manner. This is the starting point. If you see here, this is the starting point. So I already told PCI is a packet based protocol. If you see in a parallel protocol, like I already explained in the last video, in bandwidth limitation issue, you have a master, you have a slave, master to slave connected as a through wires. So in every clock pulse, what happened, data is sending from master to slave with the transaction. This we call as a transactions. So what happened, due to some noise issue, some temperature issue, but data may go into be, may not be get the properly, you will get as a, some skew related issues, as we discussed in the last video. So here what happened, instead of sending without any security, we are introducing as a packet. So whenever you are sending actual data, we will adding some data, we are removing here, we are adding here, we are removing here. So what happen, that the security will improve, that whatever actual data we are sending from master to slave or any transmitter to receiver, though the security will increase, so might be going to be correct. So in this way helpful. So there are three advantages. mainly why we are using for a PCI packet. This is the first step. If you see in a previous slide, if you see in a transaction layer, well defined, you header, where is the place, where is the ECRC, where is the LCRC. So packet is well defined. You can add the data, you can removing data from another end. So everything gets very clear. So packet is well defined. One more is the framing symbols defined for packet boundaries. So framing symbols, if you say in a start and end conditions, so that is the packet boundary. You whenever start data is come, next we will get as a sequence number, next we will see as a header. So everything gets very clear. These boundaries will help you to more accurate to fetch the data from that packet. So by seeing that packet, this is we have a ECRC, so those boundaries will very clear. One more point is the CRC protected for entire packet. That is a very good point actually. If you see in a previous slide, in ECRC is protecting this much data, LCRC protecting this much data. So whenever you are sending data from your transmitter to receiver, any master to slave through without packet, you are sending transaction with wires. So what happen? You may be corrupt from your receiver end. You don't have option to check the anywhere anything here. So what happen, CRC will help you to detect that error. So and so packet I'm getting error, so we have to resend again to increase the data integrity. So in this way, packet formation is very helpful to increase the performance. If any question, please let me know. For next video I will upload the remaining slides.